LLMs can also act like agents. That means you can talk to these agents. They will then do a very specific job using one tool. So here, these tools can be Synera. So if you give the agents a workflow to basically manipulate and run, they can basically take over the task of using this workflow and getting you the results. And all of this today is just possible by simple prompt engineering. And what that means is all these agents need to know is what is the input, what is the output, and they are intelligent enough to already understand what is the relationship between them. And in return, what we get is this really smooth interaction between software. So we as engineers can really think about concepts, engineering, taking decisions, and these agents can do the process of running the workflows, running the simulation, and get back the results to us for us to take decisions. And I want to show you a demo in this direction. And what I have here is a workflow that is basically has an agent sitting on top of it. So the kind of interaction I have with this workflow is all through text. So I have a bunch of commands like you saw in the previous video. And here it's again the same parametric bearing that I want to control. So you see all my prompts are in that direction. So I have a couple of cat creation prompt, like many of you mentioned, this is one important step. I also have some FEA, and what I also can pass these prompts and get the corresponding AI response back. And what the agent does is it basically controls these custom nodes here. So I already have my first prompt given in. It's already going to the agent. So let me start a new session here. And I'm starting a new session. And the AI already tells me I set the bracket parameters. I did not, simulation not yet started. And you see already, if I turn on the bearing body, I can already see the bearing generated. So this was my prompt that create me of this width, this height, of all these geometrical parameters. And if you check the workflow, you also see all these parameters. The next prompt that I can set is, can you increase all dimensions by 10%? And these agents also have memory. So it says I increased all the dimensions by 10%. And we see the body will, you see the parameters also increased from 100 to 110. And everything basically increased by 10%. And as a next step, what I can also do is ask some other kind of prompt, like let's start a FEA simulation now on top of this. And that is my next prompt. I also say this is the force value. And since the agent has access to all these custom nodes, what it can do is trigger the simulation. It says simulation started with specified force values, and we already see the results coming out here. So we see the result here. And the cool thing about these LLMs is they are multimodals. That means they can do much more than text. And that is my next prompt. Can you look at the results and modify the parameters to what you think can make the stress equally distributed? So therefore, I plug this in. I wait some time for the model to look at this image and do some action. So now it says, based on the stress distribution, I have adjusted the parameters to improve stress distribution. Now, this is not physics driven, so it's just the agent taking decision on its own. So it's setting some parameters here in a way it thinks it makes sense to it. And then we also get the simulation result back. So this is one way of using agents inside Synera. And as a quick teaser, everything here is done inside Synera. Again, through web nodes, through dictionaries, and just giving it a good prompt, and thereafter it controls everything. Now, a good way to extend this is to imagine at an organization level. So we are probably working with a lot of colleagues, and we are all developing some kind of products. So imagine something like a multi-agent system. So what a multi-agent system means is that there is a master agent, and under which there are a lot of workflow agents. So like you just saw a couple of minutes back, these workflow agents can control one workflow, but the master agent can then control at a system engineering level all the workflow agents. And this is the demo I have here. So what you see here is the same workflows, but I have 3 different parts. So not just a bearing, but sorry, not just a housing, but a bearing, a bolt, and another part. And I have master agent sending a response to workflow agent, and then workflow agents basically triggering these workflows. And as I mentioned, these are more on the system engineering level. So depending on the number of parts I have, we can give a system requirement. For example, my first prompt is I need not just a part, but a whole bearing assembly of these system requirements. So let me try to start it already. So I start the whole system, and first I will get the response from master agent. So the master agent says, sure, I have generated the prompts to the workflow agent. So the master agent is writing jobs to workflow. The workflow agents are basically creating all the bodies. So you see, we just generated the whole system, not just one single body. And the next prompt would be something like, okay, let's update the requirement that needs to bear double the load of previous one. So now when I give this prompt, the master agent will first talk to me. It will tell something, yeah, I have updated the prompts. And then it will also write the requirements to the workflow agent. Please set these parameters. And the workflow agents will then call the Synera workflows to create basically those parts. And that's how we can imagine a group of agents working together. And this is all possible today in Synera. And all of this is again generated with the same web nodes and dictionaries inside Synera.